which trusts my phone and my keys. It doesn't trust someone else. So there's this different kind of security model that emerges because of that. And our goal is to make that kind of security really easy to use for application developers.
I just started recording. I hope it is okay, Mrinal?
Oh yeah, absolutely. Yeah, perfect.
Hi, Mrinal, just wanted to ask, is it MQTT under the hood? MQTT? Do you use message queue?
No, we don't use MQTT. The reason we don't use MQTT is MQTT inherently has no notion of security in the protocol. So to secure MQTT, you have to use a secure channel protocol like TLS potentially. But my experience with IoT deployments has been that oftentimes the data flows through multiple types of networks, right? So the data might start in a low power wireless network, then enter the TCP network, and then enter some cloud internal network, etc. And if you use TLS, TLS has to terminate where the network connection terminates, right? So you can't get end-to-end secure connections because the first hop, which was your, LoRaWAN hop, needs a completely different secure channel, and your second hop, which was your TCP MQTT hop, needs a completely different secure channel, and so forth. So the gateway in the middle all the data is exposed at that gateway. So to avoid those scenarios, we're building an end-to-end secure channel ourselves. Now, technically, someone could tunnel MQTT data through the Ockam secure channel if they wanted to, but it will be suboptimal. Our protocol already provides messaging.
Okay, yeah, great.
So Mrinal, this is Akshay. So when you for mobile, like if I'm sending some request to cloud server, and from that, like it's going to particular device, let's say switch or maybe a TV or something like that, or maybe heater, something like that. So we don't have that kind of security channel present at the end point, where the request need to be processed. So how you guys are ensuring that like the particular switch or maybe other applications are securely getting the data?
So we are building SDKs for embedded devices and
so all things will be
cloud services and right, exactly. So the idea is that someone who's developing the device and wants the device to be secure uses the Ockam SDK and calls 2 or 3 functions, not writes thousands of lines of code. Instead of doing that, they call 2 or 3 functions to create a secure channel. And similarly, the person writing the phone application also calls 2 or 3 functions to create a secure channel, and then everything just magically works. That's the user experience we're going for.
Okay.
So is it more for IoT, or like can anyone use it?
I think it's applicable in all sorts of scenarios, because for example, you could. It's useful in scenarios where you have lots of things talking to lots of other things, and they want to do it securely, right? So you could imagine that when you have hundreds of microservices talking to other hundreds of microservices, you have very similar problems as thousands of devices talking to thousands of other devices, right? It's the same set of problems. And if you want to do that securely and in a scalable way, you need a easy to use programmatic secure channel API and an SDK, and that's kind of what we're trying to build. So I believe it is applicable in lots of scenarios. What we're thinking is that a lot of computing that is sort of centralized in a cloud, not centralized is an interesting word there, but a lot of computing that is in the cloud today will move further and further towards edge environments. And especially in those settings, there is no data center boundary. There isn't a 100 people security engineering team protecting your edge environment. And so these kinds of security use cases become super critical. So what we're trying to do is make it so that those environments can be secure.
Yeah. So actually, I was talking with a few people this week about our meetup and your talk. One of the question was, is it related to blockchain or how is it related to uh, blockchain? The question.
So
Like,
technically in our current code, there is no.
Can we use this for blockchain? It was some interesting thing.
Oh, for building a blockchain, maybe. I have not thought of that use case, but we in our code don't use a blockchain. I have a distributed systems background and I find the technology very interesting. I think consensus, like for example, even React does consensus, right? And yeah, Raft algorithm does consensus. A lot of systems use that in a distributed setting. So consensus is an interesting problem on its own. And then you add to that this notion of Byzantine fault tolerance. That's really interesting technically. From an application standpoint, I think the applications, we're still all discovering how to use that kind of capability in a real world application. In the Ockam system, one use case that we have considered a little bit is, so all of these devices that we're trying to enable secure communication between will need to maintain their identifiers and the corresponding cryptographic public keys somewhere. And you could technically store that in a database, but then whoever has the database, if the database is single admin database, then whoever has the database could change my key without letting me know, right? So where a blockchain could be interesting is if the party managing the database is not one party, but it's 50 parties. And so now you have to get majority consensus between 50 parties to change my public key. And that's a better, more secure model than convincing one party to change my public key or threatening one party to change my public key, those kinds of things, right? So in that setting, we think blockchain is interesting for Ockam use cases. So we might actually use it as we go forward in implementing stuff.
Nice.
Mrinal, how do you trust an incoming connection? Do you use client-side certificates?
Yes, right. I think that's the requirement. Basically, if you don't have regardless of Ockam, if you're doing IoT security and you're not doing mutual authentication, your system is vulnerable to all sorts of problems.
Yeah.
So there should be mutual authentication, and yes, we in our system also have mutual authentication. We have not yet implemented X509 certificates. We're using just public keys and exchanging things, but we have a plan to get to X509 certificates.
Yeah, great.
Also, how is the flow of today's talk, Mrinal?
So the plan today is I kind of want to spend the first half just generally talking. The title of my talk today was Fighting Complexity. So I want to spend the first half of the talk just talking about what do I mean by that? Like, what does complexity even mean? And why is that a problem in software? Not in an abstract sense, but concretely, like what can we do about it and what does it mean? And then the second half is more sort of Elixir-centric approaches to addressing complexity. That's the plan.
Okay, let's start then.
Right.
Do we have slides?
Yes.
Okay.
All right. Let me know if you guys see my full slide screen.
Yeah, we can see it.
Okay, awesome. Actually, I need to move the window a little bit so I can. Okay, And you can still see my screen?
Yep.
Yep, you can see it.
Okay. All right, I'm going to start. So this title, you know, it's a nod back to a book that I will a little bit later in the talk actually link to, that I think is a pretty interesting book that all software engineers should read. The point that is interesting about software is that software has almost no constraints, right? So, or it has much less constraints than the physical world. In the physical world, you have laws of physics, etc., that limit you. But in the software world, we do this all the time, right? We create games that are completely fantastical, and they people can fly in that game, or like the laws of physics don't apply, right? So the constraints of the software world are very different from the constraints of the physical world. So we can build all sorts of things in software. We can make pigs fly if we want to, right? And essentially my point being that if you can imagine a system, you can probably build it in software, right? But the greatest sort of limitation, when we're building software is our ability to understand the system that we're creating, right? That's really where things get difficult. Because if we can understand it, we can probably code it. It's the understanding it that's hard. And that's the book that I mentioned at the beginning of the talk, which is John Osterholtz's A Philosophy of Software Design. A big chunk of my talk today is taken from that book. All right. So as we're building software and we add new features, our code obviously evolves and it naturally starts to get complicated, right? Dependencies emerge, things depend on each other, functions depend on each other, modules depends on each other, etc. Right? So as we add features, there's a natural tendency to become more complex. And over time, this complexity kind of accumulates, right? And more complexity is getting added, and it happens in small increments, right? So there's no, it doesn't one day appear and become complex. It's just like slowly we're doing things that make the system complex. It starts to become, as the complexity is accumulating, it starts to become harder and harder for us to keep all of the information in our heads, right? And because the system is becoming complex, and we're struggling to keep all the things in our minds, it becomes harder to add new features because we have to think about multiple things before we can add a feature, right? It slows us down. And of course, if we have all of these complex things in our head, we could miss one detail, and that's how bugs get created, right? We forget to take care of one problem, and there's now a bug in the system, which then we have to go fix, and it further slows us down. It may break other things, etc. Right? So there's this cumulative set of problems that start emerging when a system starts to get complex, where it's harder and harder for us to add new features, and we keep getting slower and slower. This effect obviously multiplies the more people, depending on the number of people that are working on the code base, right? If I'm the only one working on it, I can probably keep all the code in my head and I can kind of work with it. But as more people get added, with every new person, this complexity can accelerate really rapidly. So eventually, in every system, complexity can potentially accumulate to a point where you can't make progress anymore, right? And progress can sort of stagnate and costs can grow really, really rapidly, right? That's how projects fail. So in my mind, creating good software with a team is all about fighting complexity. We can, if we do this correctly, we can continue to continuously improve our code and add new things. But we have to continuously focus on this problem. And it's about building stamina, right? So simpler, less complex design allows us to build larger, more powerful systems before the complexity hits us, right? Before it gets too complex for us to keep it, to understand it and think about it, right? So we need to somehow build this design-based stamina that allows us to go further in our endeavors rather than get hit by complexity early in our project. So what do I mean by complexity? I've used this word now several times in the last few minutes. My fairly sort of crude definition for the purpose of this talk is anything related to the structure of the code base that makes the code base hard to understand and hard to improve, right? Even it could be to varying degrees, but anything that makes any structural thing that makes things hard for us is complexity. And there are some symptoms you can see in your code base when the code base is starting to get complex. One of the things that happens is change amplification. So you want to change something simple, but to change it, you have to go change code in 5 modules or 10 modules, sometimes 30 modules, just because you added a type somewhere or you added an argument to some function. Suddenly you have to go touch lots of files. That's a symptom of complexity starting to build up in your code base. Another symptom is what John Ostra's books calls cognitive load. So if to add a small feature, you have to consider lots of things, you're in a cognitive load problem, right? So if to go make a small change to one function, I have to go think about where all the state of this function may be. This is actually really well illustrated with object-oriented programming. In functional programming, the state of what the function is doing, the state that the function is dealing with is all in the function, right? So it's easy for us as Elixir developers to work with the inputs and outputs of a function. But in an object-oriented programming language, the object can inherit from lots of things. It can have state that is just spread all over the code base. And so it becomes hard to think about what all could get affected if I change one line of code, right? So if you're in the situation where changing one line of code requires you to go consider a bunch of other things, then you're seeing a symptom of complexity around cognitive load. In Elixir code bases, it can also happen because your module depends on lots of other modules, and your module calls functions and types in lots of other modules. So these kinds of things can happen all the time. One thing that's interesting here is a lot of times people will go, okay, let me, because I've been told to not repeat myself, let me do something that basically boils down everything that's going on into some simple line, because I'm not trying to repeat things. But oftentimes, because you're trying to avoid that repetition, you can create a situation where you've increased the cognitive load of the person reading the code, because they now need to go understand things because you were trying to avoid repetition. So that's another symptom. And the third symptom is this is what the book that I referred to earlier calls unknown unknowns, which is that I need to make a change, but it's not obvious what are all the things I need to change to add this new feature, because things are obscure, right? Things are hidden somewhere and I don't really know what could happen. In Erlang Elixir code bases, I've seen this happen around when people don't wrap messages in function calls. Sometimes there are messages flowing in the system that aren't well documented anywhere. And this can really sort of throw someone trying to add a new feature. So okay, what this gives us is we need to tackle complexity. We need to minimize change amplification. We need to minimize the cognitive load someone should have to make a change. And we need to make the code obvious, right? We need things to become super obvious when someone's trying to add a feature. They shouldn't have to go ask me what all needs to change. It should be obvious in the code, right? They shouldn't have to ask the author of the code. It should be obvious in the code. So given these three symptoms, complexity is really caused by two things. Dependencies and relationships between modules and functions. If you have lots of relationships and lots of dependencies, then you can have complex code, because to make one change, you have to change lots of other things, because this function that you're trying to change is called by lots of other modules, and they expect to pass specific parameters, and you're about to change the parameters. So now all of those other modules have to be changed, right? That's the problem dependencies can cause. Obscurity can be, I need to make this change, but it's not obvious that to make this change, I also have to go change this other function, right? That relationship isn't obvious. So complexity is really these two things. And our goal is to deal with these two things in a better way. And as we go forward in this slide deck, we'll discuss how we can deal with these two things better using various Elixir constructs. But before we go there, I want to address a couple of mindset things. So the mindset I commonly see in a lot of programmers, especially early in their careers, and I also had the same mindset, although it's slowly changing for me, is this mindset of tactical programming. The focus is always, let's get this working, right? It's how quickly can I get this working? I'll worry about the details later, right? I'll worry about the design later. I just want to sort of see something working. And that's a good thing from an iterative standpoint, and you should, iterate. But what's not okay is to just rush something to get it working and then forget about it, right? Because then you've created complexity, because you've now done some work, taken some shortcuts, just to tactically make the system behave a certain way, but you've created a bunch of sort of design problems in your system. A much better way to approach your code is to think strategically about your code, right? And John Ostrud in his book says, the first step towards becoming a good software designer is to realize that working code isn't enough. It's not acceptable to introduce unnecessary complexities in order to finish our current task faster. The most important thing is the long-term structure of the system. Our primary goal must be to produce great design, which also happens to work. Of course, our code should work, right? That's the given. It's if we can design the code well, we leave ourselves the strategic advantage of being able to fix minor problems as we go forward. But if we design our code poorly, today it might work, but tomorrow when I need to go debug it, I might not understand it even myself, let alone if someone else has to debug it. My first job 16, 17 years ago now was maintaining a system that was written 15 years before that. And it had all sorts of these problems where someone had left a little hack and now it was my job to fix that hack, but it didn't say how to fix it, right? It was just there in the code. And through lots of debugging and trial and error, we would discover it and then go fix it. So programmers who are strategic programmers, who think about the long-term life of their software, focus on the design of the software, because otherwise I myself may not be able to fix problems in it in a few days, and complexity might just crumble our system. There's a good picture in John Ostra's book that I really like, where he says, you know, for a short period of time, and my experience is this is only like, you know, one sprint long, right? You can gain an advantage by taking a tactical approach, right? You can finish your goal for the 2-week sprint faster if you take a tactical approach. But what happens is your total progress starts to stall if lots of people are taking tactical approaches. Instead, if you take the strategic approach, it might be slower in your sprint, right? So instead of taking 2 weeks, it might end up costing you 3 weeks to implement the whole feature. But long-term, you don't run the risk of running stagnation, right? And long-term, like even though we're talking in terms of like, I'm saying long-term, typically I think this starts to manifest in like, you know, things that you did in this sprint with 3 or 4 sprints later. So in like 2 months or 3 months, they'll come back to bite you because you took a tactical approach in this particular sprint, right? So here's an example of what happened in the Ockam Elixir code. So we had someone join the team who made a GitHub contribution, and he was working on some functionality for about 2 months or so. And in two months later, I kind of started reading the code and I was trying to understand what's going on over there, and I couldn't understand it. It was too much complexity. I just couldn't even think about the components of the system. And then Mix has this, the Elixir Mix command has this xref option where you can generate a dependency graph of your modules. I highly recommend everyone use it to see what their code structure looks like. And this is what came out of it, right? So I'm sure you can't even read what's going on, but this is the definition of spaghetti code, right? My wife, I was showing it to her, this slide deck when I was preparing it. She saw this slide and she's like, you know, the Hindi term, kuch much. I don't know if there's if everyone's familiar with the term, but she's like, what is this kuch much, right? That's what our code looked like. And it didn't take long. My point is, and John Ostrad in his book points this out. He says, you can sometimes get people on the team who are tactical tornadoes. They come in, they can get stuff working pretty quickly, so everyone feels like progress is happening. But what's happening to the code base is kind of like taking the code through a tornado, and after it's done, it's very hard to fix it. Here's a slightly zoomed in view. In this example, there is you see let's take one of these. Let's take the protocol decoder. See the number of incoming arrows into the protocol decoder. So if I am to make a change in the protocol decoder, I better make sure that all of those other arrows didn't break, right? And that's a serious problem. Because for now, this is the change amplification problem in a picture, right? Because if I change something here, let's say I change a function signature of the decoder, all of those other modules are about to break. And what's worse is there are modules depending on other modules that are all many-to-many relationships. And so this can very quickly spiral to a point where you can't even understand what's going on in the code. You can never fix a bug. I've been on projects where I've seen teams play what I can best describe as like the whack-a-mole game, if you've ever played it. But basically, you fix one bug and another bug appears, and you fix that bug and that other bug appears. And this kind of code is guaranteed to produce that problem. So, all right, so how do we, like, this is great. We talked about all the problems that could happen because of complexity. How do we deal with it? Well, there's the simple stuff, right? Remember we said one of the symptoms is cognitive load. If I have to think about too many things, I can lose track of some of those things, and then I can make mistakes. So how do you avoid people making mistakes? You make your code consistent. How do you make your code consistent? You run it through a formatter. Everyone uses the same format. So it reads the same. Subconsciously, it looks the same to me. I can spot visual patterns in the code. So use a formatter. Use tools like Credo, which do linting on best practices. Credo, if you're not familiar, is an Elixir library that does static type checking and linting. Static linting, not type checking. Which reminds me, use tools like Dialyzer, which do static type checking, even though the type system in Elixir is fairly loosely typed. And then, of course, the easiest part is good names. Good names help the reader understand the intent of your code, right? You could use a variable X to represent something, but then someone who's reading the code can't understand what that X is. But if you name it something that really describes what is in the variable, that's much better. And I am personally, I know different people have different preferences for this, but I am personally of the opinion that long names are a really good thing. It's fine if your name is long. Don't worry too much about it. Code should be optimized for readers, not for writers. I, as the writer of the code, is going to write that code once. That code is going to get read hundreds of times over the life of the code. So it's okay if I have to type 5 more characters or 10 more characters or 20 more characters. Use a good name. And comments should describe why you're doing something. Right? So comments shouldn't be sometimes, you see in a comment, there's a function called, or let's say a module called bridge, and the comment above the module called bridge will be, this is a bridge. Does that make sense, right? I'm reminded of a cartoon, but basically that comment is not helpful at all, right? It's stating the obvious, right? Comments that help the reader understand why you're writing certain lines of code. So this is the simple stuff. This is like the bare minimum bar of good quality code. This should just be a given in your code base. Now let's get to the more interesting things. So,
I have a question here.
Yeah, go ahead.
So the code will speak itself what is happening, and should the comment be why is this why we made this change?
Why I decide why what is happening, right? Like, what is the reason for me to provide this function? What is the reason for me to add these two numbers together? What is the reason for me to exit this for loop in this particular condition, or exit this map function in this particular condition? Those reasons are things that we are thinking about when we are writing the code, but then we don't write them down anywhere, right? So someone who's changing the code doesn't know that reason was there, right? So it's the obscurity problem that we talked about earlier, which is, or the unknown unknowns, right? It's if it's not written down anywhere, they don't know that they can't change the length of this array, or they don't know that they can't change the arguments of this function because other things will break, right? So make those things obvious.
So just we are referring to GitHub commit, git commit, or comment.
Oh, both.
Yeah.
I was referring to actual like comments in the code as well, because I think actual comments in the code should describe. So if I have like 5 lines of code that is doing something, sometimes it is really, really obvious what the code is doing, and that's fine. But if it's 10 lines of code, it isn't usually obvious what the code is doing. So I think that there should be some kind of code block above, comment block above it that says, hey, in the following 10 lines, I'm about to do this because this is the scenario I'm expecting, right? Or I just realized I might be looking at the wrong. Does it look like I'm looking at you, or does it look like I'm looking to the side? It probably looks like I'm looking to the side because my camera's over here. Sorry about that. So my point was that the moment your code gets complex and you feel like it's doing 4 or 5 steps, explain why you're doing those 4 or 5 steps. Ideally, those 4 or 5 steps are encapsulated in a function, and then you just write a comment above the function explaining why the function exists, right? But if it can't be broken down into a function for some reason, then do it inside the function. But explain the why of the steps, not just the what. The what should kind of be obvious from just reading the code because your names are good. All right, so the next topic I want to touch upon is modular design. And you might have heard of this term a lot, right? People use this a lot in software discussions. But what is the purpose, right? Remember, our challenge was that slowly the system is going to get complex. There's no way around that, right? But what we could do is make it so that when someone is making a change to the system, they don't have to think about all of the complexity of the system. Instead, they can focus on a small fraction of that complexity. That's what the purpose of modular design is. Our goal is to make it easy for someone to make changes to the code because they don't have to think about all of the complexity of the entire system. They can focus on thinking about the complexity of one function or one module. That's the purpose of modular design. I should point out at this point that modular design doesn't mean more modules, right? And I've seen this happen in code bases where, because the code base is getting really complex, people will go in and say, okay, I need to make this more modular, so I will break everything down into modules. And now you have hundreds of modules that are actually worse than one good module, because if let's say I had something that should be in one module, instead of it being in one module, I've split it into 7 modules. Now the person who has to make a change to that code has to go read 7 modules, even though they're small modules, but they have to keep context switching between files. And so it's worse than reading one module, right? So modularity is about encapsulation. It's about encapsulating the complexity of some piece of our system so that our team can work on the other parts of the system without being exposed to this complexity of this module. And if someone is working on this module, they can work on this module without worrying about the rest of the world. That's our goal, right? Our goal is, if I'm working on one module, then I shouldn't have to go read 10 other modules. I should be just limited to that one module. I should be able to understand what's going on in this module and make changes to it. Similarly, if someone is working on other modules, they shouldn't have to know too much about my module. They can know a little bit about my module, but they shouldn't know too much about my module, because then they have to, that problem can just multiply. And so if I'm creating that problem of everyone needs to know about my module, then other people do that, and you get the picture that we saw in one of the dependency graph slides I was showing of the Guchmuch. So you don't want that. In Elixir, even though modular design talks about modules, in Elixir you can do encapsulation in functions at the function level and at the module level, right? So if you can have a function that encapsulates and hides the complexity of doing some complex calculation. Like, for example, in the Ockam code, it could be the AES GCM encryption algorithm. And that could just be encapsulated into one function. And that's ideal because anyone out in the world just needs to call the AES GCM function. They don't need to go figure out how that complex cryptography algorithm works. right? So that's one way of doing encapsulation. Another thing you can do, another way you can do encapsulation in Elixir is inside a module. And this is typically the case when you have like processes or gen server based Elixir modules where multiple functions are kind of interrelated. And so you put all of them in one module, and then you encapsulate all of their functionality in that one module. And this is where there's one concept, again, from the Ostrad book that I like a lot, is this idea of deep modules. So he says in the book, the best modules are those that provide powerful functionality, yet have simple interfaces. So powerful functionality, simple interfaces. That's what we're aiming for. And this is a good picture that illustrates that. You want a deep module. The light gray part of this picture in the module is functionality, the benefit, right? So the module does lots of things, but the interface is something small, like one function or two functions. Versus the second case of a shallow module, where all the functions of the module are exposed to me. Now, it has some benefit, but it also exposes all of its complexity to me. I have to figure out everything about the module, right? So better modules are deep modules. Here's an example from the Ockam Codebase, where I'm creating a secure channel. And to create a secure channel, I need a vault, an identity key pair, and an onward route. That's okay. I need 3 variables, and I'll need to create these variables. So it's a little bit of information I need to deal with. But if I give this function these 3 pieces of information, it magically will do a lot of work for me. It'll do a handshake with the other party. It'll do all the cryptography involved in the handshake to create a shared secret. It'll do proofs of those public key secrets. If it fails, it'll try to do retries. Like a whole bunch of functionality is encapsulated behind this very simple interface. It's a deep module. Another one I like from the Elixir community is the flow library, right? So the flow library can allow you to express computations on collections similar to enum and stream, but these computations are happening in parallel, right? And think about the complexity in that. To do computation in multiple processes, but only expose this very simple interface to you is very hard. But by doing this, we make it really easy for our users. More importantly, we expose only minimal detail about the complexity that is hidden in the flow module to the user. So we're free to change details of the flow module as long as we can keep this interface consistent, and that's important. There's a law, and just like there's Moore's law or other laws in computing and etc. There's this Hiram's law, which says if you have sufficient number of users, it does not matter what you document as your API. Everything that is observable about your code will be depended on by somebody, right? So remember, so far in this talk, we've said complexity is caused by dependencies. If other people depend on my code, it's harder for me to change my code. If lots of people depend on my code, any change I make propagates to all of those places. So dependencies are a serious problem. And if I have a module where I expose 20 functions, or sometimes I don't even want to expose the function, but because my habit is to write def instead of defp, I have exposed the function. What Hiram's law says is if you've exposed the function, some user will decide to call the function, right? And so now, even though you didn't intend that function to be part of your API, it is part of your API in that module. And it has created complexity. So you don't want to do that. Use defp liberally. I, in fact, sometimes write my entire module with just the defp calls, And then after I have the module functioning, I very carefully decide what the interface to this module should be, and then write my public-facing def functions. So what we're trying to achieve is loose coupling, right? Components in a loosely coupled system can be replaced with alternative implementations that provide the same service. So if my, going back, right? Let's take this example. So I'm doing the secure channel, and let's say tomorrow there's a new cryptographic algorithm to do a cryptographic handshake. I, as the maintainer of the Ockam secure channel module, could replace that entire implementation with a completely new algorithm, and any of my users wouldn't have to change their code. That's loose coupling, right? There is still some coupling. They are coupled to this function and all the parameters of this function, but it's a very small surface area. Versus imagine if what I exposed was 20 functions with 3 or 4 parameters each. Now there are 50 contact points. And if I change any one of those contact points, someone's user code will break, right? So we don't want to do that. Same is true for the flow module. They can change how they do partitioning. They can change how do they implement the reduce function, and none of that will matter to the users of the code. And that's what we mean by loose coupling, a small surface area of exposure to other modules. One way of doing loose coupling is polymorphism. So polymorphism is the ability to present the same interface for different underlying forms. This will, if it's not clear, I think will become a little more clear as we look at some examples. But the idea is that my interface, my function call, my parameters should stay the same, but I should be able to replace implementations behind that, right? That's what we're trying to do with polymorphism. So Elixir has lots of functionality that enable polymorphism. One obvious functionality is messages, right? So Elixir processes or Erlang Beam processes can send messages to each other without caring about what the other process is, right? You don't have to know anything about that other process. All you have to know is the process ID, and you just call the kernel send function, right? So what that process will do with your message, you don't care. You can send the message, right? This is polymorphic because I can send the same message using the same process ID structure and the same send call to lots of different types of modules. So for example, all of us write gen server based modules, right? The gen server call function doesn't care who wrote that module. It still works for everybody because it works using messages, right? The gen server call is just going to send messages to your gen server implementation. So if I'm a user of the gen server call, I can just call gen server call and it just works. So messages are a polymorphism tool in Erlang and Elixir. It's not a very good polymorphism tool, I think, because it doesn't have any notion of types. So it's not strict about the contract between me and my user. The contact surface is very small. Any process, any message can be sent over this surface. This can be problematic because it can quickly sort of become, it's kind of too general a tool, right? So it's often useful to wrap your message-based polymorphism in some kind of a function and use that function and build polymorphism off that function interface. Another tool for polymorphism in Elixir is behaviors. So behavior is simply a module that defines a specification that other modules can implement. So here's an example of that. So in Ockam Vault, the we need a hash function, right? And we need this SHA-256 hash function. It should receive a input binary and output a hash of that binary. That's what the function does. But in IoT systems, lots of different hardware provide lots of different implementations of SHA-256 functions. So for example, I could have a cryptographic module that does hashing in the module, or I could have some kind of special accelerator in my processor that does hashing, etc. So by having a behavior callback defined in this Ockam vault behavior for SHA-256, I can write lots of implementations of the Ockam vault behavior, right? So I can have a Ockam vault implementation that uses the secure enclave processor in my MacBook. I can also write an Ockam vault implementation that uses the ARM trust zone trusted execution environment. Or I could write a completely different Ockam vault implementation that uses a HSM in the cloud, like Azure HSM or something, right? So because I have abstracted my interface into this behavior definition or this spec, Elixir allows me to write lots of implementations of this behavior and use them interchangeably. So any application code that is calling this SHA-256 function will not need to change if I replace the secure enclave implementation with a YubiKey HSM implementation, right? So that's the benefit of behaviors. They allow us to replace underlying implementations of modules, which in turn allows loose coupling, right? Why does that allow loose coupling? Because remember what was loose coupling, right? Loose coupling was this idea that alternative implementations can provide the same interface, the same services. So I can have application code that only depends on this one very simple function, SHA-256, and I can replace things behind it with deep modules, one that is interacting with some cloud service HSM, another one that's interacting with the secure enclave in a MacBook, et cetera, right? So this decouples my vault implementations from the rest of the system code. And that's really nice. That's why polymorphism is nice. Another tool that you may have come across for polymorphism in Elixir is called protocols. So protocol is a group of function headers that a data type must implement if it is to be considered implementing that protocol. An example of this is the size protocol from Elixir, where anything that wants to provide a size function can implement this protocol. So for example, a bit string type could implement the protocol and call the byte size function. A map could implement the protocol and call the map size function. A tuple could implement the protocol and call the tuple size function. But what's nice about this is that if I am the user of any of these data types, I can write functions that use the size protocol and can accept data of any of these data types. So I don't have to couple my application code with the implementation of the size function, right? So my data is not coupled to a particular data type. My code is not coupled to a particular data type. My code is general across a bunch of data types, and this can be very useful. And I'll get into an example of how this is useful in a real world scenario in a second. But oftentimes people will, at least on our team, I've had people ask me questions between when to use a behavior versus when to use a protocol. And the way I think about it is that a behavior is useful when the data you're dealing with is the same, but the code that operates on that data can be replaced, right? So it's the same message that you might want to hand to multiple different types of function implementations. That's where a behavior is useful. A protocol is useful when the code that is dealing with the data is the same, but the data is of different types, right? So the code that wants to print the size of a data type is the same, but the data types, the user of this code is the same, but the data types that can come into the code can vary, right? That's where protocols are useful. Okay, another polymorphism tool in Elixir is functions. So because in Elixir, functions are first-class citizens, you can pass function, you can store a function in a variable, you can pass a function as an argument to another function, right? And this is really useful and powerful from a polymorphism standpoint, because what it allows is pluggable logic. So I can write code that operates on a function plus some other data. A good example of this is from the Elixir library, this map function, right? So enum.map will take any enumerable and pass it through that function, pass every item of that enumerable through that function. Excuse me. What's nice about this is that the first parameter of the map function is a protocol enumerable. And a map implements enumerable, a keyword list implements enumerable, etc. Right? So lots of data types can be passed to this function, but the code of the enum.map function doesn't need to change. That's polymorphism in action. The other part of the polymorphism in action is also in the second parameter of this function, which is the anonymous function that we're passing in, which operates on the first element of, operates on each individual element of the map of the input enumerable, and changes it in some way, right? Now, what's nice about this is that this is polymorphic because the map function doesn't need to change, and I can plug in different types of parameters that are in place of that anonymous function that I'm plugging in. I could pass in a function that multiplies by 3 or multiplies by 4 or multiplies by 400. The implementation of enum.map doesn't need to change. So passing around function, either anonymous functions or captured functions or module function attribute tuples, MFA tuples, you might have seen those in various Elixir or Erlang code. That's a really good way to do polymorphism as well. All right. Now I kind of want to take my last few minutes talking about a design approach that has worked really well for me while working with complex Elixir code bases. So this may not necessarily work for you, but it has worked really well for me. And I think it's a good design idea. And so I want to sort of leave you with how to approach this. So this pattern is called dependency inversion. It's used in lots of programming languages. There are books that have chapters about this pattern, etc. But I have found it really useful in Elixir code bases. So what is the idea? The idea is that a high-level module should not depend on low-level modules. Both should depend on an interface. Our tools for creating an interfaces in Elixir are messages, behaviors, protocols, and functions. Those are our tools to create interfaces in Elixir. And what dependency inversion is saying is, if I have a high-level module that needs to use some underlying functionality, it shouldn't directly call that underlying functionality. It should instead call an abstraction, like a behavior. Because then what I can do is, if at a later point in time, I need to change the implementation of the behavior, I can change it. Or if my implementation of the behavior is really complex, the high-level module is not exposed to that underlying complexity. A good example of this might be this vault module, right? So in Ockam code, we use this vault module to implement some really complex handshake algorithms between two peers that are establishing a secure channel. And that code is complex on its own, and we don't want the complexity of that code to get mixed in with the complexity of dealing with cryptographically capable hardware like the OS X Secure Enclave or the Azure HSM functionality or the microchip ATECC 608 hardware module or whatever, right? There are hundreds of these underlying modules, and we don't want our super security critical complex protocol code to get mixed in with the implementations of these underlying things that are also complex on their own. And by having this behavior in the middle, we decouple the higher level modules from the low level modules. And that's what dependency inversion is telling us to do. Dependency inversion is saying higher level modules should not depend on low level modules. Both should depend on an abstraction. And a good abstraction usually here is a behavior. The second point in dependency inversion is abstractions should not depend on details. Details should depend on abstraction, which is, again, the same idea that low-level modules should depend on the interface. The interface shouldn't have tightly coupled code that deals with a low-level module, right? So this is important. Using this idea, the structure of the Ockam code base currently looks like this. And this isn't the first time I've implemented this structure in an Elixir code base. I've done this multiple times, and it's worked out really well over and over again. In fact, I see a good example of dependency inversion in action is also the Elixir plug module. So if you think about it, right, a plug is a behavior. And actually, before we go here, let's talk about plugs, and then we can come back to that Ockam picture. So a plug, an Elixir plug that you may have used in Phoenix applications or elsewhere, is a behavior that implements two functions, init and call, right? And it says anyone who wants to be a plug should implement the init function and the call function. Any module can be a plug as long as it implements these two functions. And then whole frameworks have been written on top of that simple interface, right? The entire Phoenix framework is majorly just dealing in plugs. And the underlying web servers like Cowboy are just providing a plug implementation, or modules to implement secure handling of cookies or a secure handling of HTTP headers are just providing a plug implementation. That can be a very simple module, right? What's nice about that is someone implementing a plug doesn't need to understand everything about Phoenix. They can just focus on writing their plug. Similarly, the people writing the Phoenix framework don't need to understand exactly what's going on in each plug that will ever be implemented. They can just implement the framework that depends on the plug behavior. And that kind of decoupling is really key to having maintainable, simple, not complex code. So in the Ockam code base, we've ended up with this picture. And it's still evolving, but I think it's interesting for this conversation. So we want to be able to establish secure channels using lots of different transport protocols. We want to do a secure channel over UDP. We want to do a secure channel over TCP, over LoRaWAN, Bluetooth, HTTP. And this is a very small subset. I imagine that over time, the Ockam code base will have hundreds of transport protocol implementations. And then at the top level, right? So at the bottom, we want to implement a bunch of these transport protocols. At the top level, we want to implement higher level protocols that don't care what was the transport, right? So a secure channel protocol doesn't care what mechanism was used to transmit this message. It just cares about what messages arrived at both ends. So to be able to build all of these complex things on top and not get really bogged down and overwhelmed by the complexity of all of these underlying transport protocols that have, some of them have existed for 30, 40 years. They're complex on their own. For us to be able to work at this level, we needed to decouple ourselves from this underlying level, right? And the way we achieved that was with this very simple interface, which provides a very deep functionality, which in the Ockam code base is called a routing function. So what routing does is it has a route function, and it can register handlers for various address types. So to the Ockam router, you can say set message handler for address type 1, set message handler for address type 2, set message handler for address type 100, and so forth, right? And this message handler is just a function. It could be any function, right? So the interface is pretty small, an integer and any function. That's all you need to do to set a handler. And then there's a second function in the interface, which is called route. And it takes only one parameter, which is message, right? So the interface of the routing system is just these two functions that allow us to entirely decouple all of these modules. The way it works is that the UDP module starts up and registers its address type. It picks an address type and it registers that address type with the router. So it says, if you have a message of address type 1, send those to me. Similarly, the channel implementation up top here says, if you have messages of address type 0, send those to me, right? And that's all. So they all know about the router, but the router is this very small interface. And then all the knowledge to implement the UDP transport is encapsulated in the UDP box. All the knowledge to implement the TCP transport is encapsulated in this box. All the knowledge to implement pub sub topics and queues is encapsulated in this box. All the knowledge to do cryptography and zero knowledge proof-based credential exchange is encapsulated in this box, right? So by doing this, we can decouple a system and create a truly modular design where if we make a change in one place, that doesn't cause changes everywhere all around the code base. And the changes that can affect the entire code base are kept to be very small, right? So this message type, this route type, and this address type are very simple types. In fact, this is interesting as well. I wish I had a picture of this. Essentially, all of these protocols may have really complex messages that they're dealing in. We don't have to expose the details of those messages to the routing system. The routing system just needs to know where is the message going. So we can use the Elixir protocol to deal with all types of messages and only have one simple constraint, which is that any message type must expose a type function that tells me the type of that message. Otherwise, the message can be anything and I don't care. So what that does is decouples routing from message types of all of these other systems. So this technique of using protocols inside a module to describe what types of data types the module can accept, and keeping the functions that are defined in that protocol ideally just one function. Oftentimes that's the case. And if you're familiar with the Go programming language, they have this philosophical thing where they say the smaller the interface declaration, the better. And I think the same rules apply even in Elixir. Interface definitions like behaviors and protocols should be really small, oftentimes 1 or 2 functions. Behaviors can be a little bit bigger, but protocols should be 1 function oftentimes. And you see that in even the standard library protocols. Like, for example, the size protocol is just 1 function size, right? And so you should strive for that kind of design. All right. And my final slide is a nod back to the book that I've repeatedly referenced in this deck. I highly recommend it. I think it's one of the best software design books available. So please check it out. And this is finally some details about me. That's my Twitter handle, and that's the Ockam GitHub, which is open source, and all the code that is open source. So if you're interested in seeing me make all the mistakes I just told you shouldn't be making, you can go check out that code. All right, thank you.
Okay, nice. We have one of the questions in the chat box. So how do I swap the underlying implementation under the hood of function that wrap the polymorphism without changing the function? I think this was posted around behavior slide.
Okay. So how do I swap the underlying implementation under the hood of a function that wraps the polymorphism behavior? So typically the way it looks like this, right? So you would have a, do you guys mind if I pull up my code editor and actually type some pseudocode? That might be useful.
Perfect.
What do you think?
Sure, go ahead.
All right, so 1 second. Can you see my? Okay. Let's see. So typically, let's say I have a behavior called, let's keep doing the example I had, right? So def module Ockam vault. And this has a function called, callback call shot 6. And let's say it just, for now, it just takes a number and returns another number, right? So we can say integer returns integer. So that's just a simplification. Obviously, doesn't work like that actually, but just want to sort of give you an idea. So, and now let's say I have lots of implementations of this vault, right? So I have a vault that is OSX secure enclave. And here I implemented the function. So I say behavior Ockam vault. Then I implement this function, which takes in, let's say, some a number, and let's say for now it just returns input into 2. This is one implementation, right? And then I might have another implementation, which might be, let's see, I'm trying to think, YubiKey. Or I'll take a better example. Let's say some kind of HSM module, Azure SSM, a little more complicated. So this one, instead of multiplying by 2, multiplies by 3. Let's say that's the behavior difference between the two, right? The interface is the same. So if I'm a caller, I can instantiate. So let's say I have a function somewhere, the module let's say this is my app, right? And I have a function in the app called run. And in run, I want to, eventually I want to call vault. Let's see. I may need to go up a little bit and change a few things, but for the time being, we'll do this. So SHA 256 is what I'm gonna call. Okay, so now I want to pass in the input, right? And let's say my input is 200, right? That's what I want to do, but this will not work for now. So how do we fix this? We need to give it a instance of a vault. And I know that's a little bit of like an object-oriented term, but that's what this is. It's an implementation of the behavior that we need to pass in, right? So our vault can be Ockam dot vault dot Azure SSM. And let's say there's an init function on all of these modules. So I call this init and I get back a vault reference, right? Maybe it looks like this. Now this generic function that I had, what I want to do is I want to be able to do this on it. What's nice about this is that if I instead decide to, instead of this one, use this one, my code below this point doesn't change, right? So I might write hundreds of lines below this point. They will all not change. But if I'm making a choice, this could be a configuration-based choice. I could choose between this one or this one, right? However, we don't have this function yet. So how do we add this function? The way this is typically done is behaviors tend to have a default implementation. So you would actually have a SHA-256 function in here. But before I add this, I need to change. No, I don't need to change it. Okay, cool. So, so I have a SHA-256 function, and this SHA-256 function takes an implementation, comma, the input. All right, and this implementation comes in, and we know that a behavior, if this implementation implements the Ockam vault behavior, then I should be able to call the SHA-256 function on it. Right, and now everything will work. So, so the way I'm able to do this is because I have a behavior that says anyone who wants to be a vault must implement SHA-256. So someone else comes in and writes this module, completely different person comes in and writes this module. And when they're writing this module, they don't need to know anything about what I do with that behavior. They don't need to know what I'm doing in my application code. They just need to implement a SHA-256 function, right? So for them, the complexity is limited to just implementing this module. For me as a user, the complexity is limited to just calling the Ockam vault function, but and maybe initializing it. So those are the two things I need to do, but I don't need to know which hardware calls have to be called, right? In OS X Secure Enclave, you have to do all sorts of things around permissions of OS X. You have to do like a bunch of complexity to talk to the OS X APIs, etc. None of that is exposed to either the user or the higher level module, which was the generic implementation. All of that complexity is limited to the insides of this module or this function. So I hope that answers the question. I see there are follow-ups. Oh, okay. I hope that answered the question. So I think because my example was exactly that. And then the other question was, what is my view on maintaining architecture design records? I think they're awesome. We should absolutely be doing it. I myself struggle at doing that regularly, but even in the Ockam repo, we're trying to, we have a proposals repository where we're trying to do design documentation. Now, there is a balance. The balance is that the trap you can fall into is the waterfall. I will design and solve every problem before I write my code. And you can spend years doing design in theory, and then when you start implementing it, it'll just not hold up, right? And that's a problem. So what you want to do is iterate, make a small, conscious, thought out decision and write it down in a ADR and go implement it. But keep these small. This, I think, at least for me, has been really helpful, and our team has been really helpful, is small design decisions, small issues and pull requests, all tied together. We're still getting better at it. We're not good at it yet. We struggle with it all the time. But the smaller you can keep changes, the easier it is for the design process to be iterative. However, if you just dive in and you're if you just dive in and don't think about the design at all, then the trap is that you can get into the tactical mode of, I'll just make this work and I'm not worried about the design problems. And then suddenly you just keep adding complexity and you end up with that spaghetti. I hope that answered the question. Do you have examples of protocols following the code we just wrote about behaviors? Sure, I could share an example.
The next question should be taken first by Yogandhar.
Okay, all right. Okay, I can try that. So the impl input did in behavior has a different signature in. So let me pull that screen up again. The rules that Elixir is enforcing are very simple. The rules are anyone who declares this must implement this function. Note that this high-level module didn't have a behavior statement in it. So it's free to choose whatever signature for this function. That doesn't matter. What really matters is anyone who uses the behavior Ockam vault must implement exactly this signature. I hope that answered that question. There's the chat. Okay. All right, great. So going back, do you have examples of protocols? Since I have my screen up, I can pull up some examples of a protocol. Let me see. So, all right, this one's a good one. So this protocol, actually, let me simplify this. A simplified view of this protocol is type. And another one I'll pull up is message, let's say. And I'll explain what they're doing in just one quick second. This is another protocol. So a concrete message structure let's call it UDP message. So to be a UDP message, I might need to track. Actually, let's do this with the address first, because that might be a simpler example. So let's see, let's say this is a UDP address. And what's a UDP address? It's a IP and a port, right? So I need to define these two things. But I'm also saying that, let's forget about this one for a second, okay? We'll come back to it. I'm also saying that if this address wants to play well with the Ockam router address, then it needs to have a type implementation. So I also need to store a type variable in my struct. And I need to define a function called type, which will return, let's say, address, and it will return address.type. So what's nice about this is I can also have a MAC address. And then I don't have an IP and a port. And the MAC address is just value, right? It's a 6-byte value or 8-byte value typically. And my implementation still returns address.type. I could even have a hard-coded value here, right? I could decide that the address type of, actually that might even be better. I could decide that the address type of MAC address is 2. And I could decide that the address type of UDP address is 1, right? Now, if I have a function called, let's say, route, that receives a message, and in Ockam, the way it works is that messages have a onward route, message have an onward route. This onward route returns a list. And this list, I care about the first address. I don't care about the rest. Okay, so I've extracted the first address. If you're unfamiliar with this syntax, this is just pattern matching on the first element of the list. So I now have the first address. Let's call this address, okay? So now what I want to do is I want to get a message handler for the type of this address, right? So I need to find the type of this address. But these two address types that may come in as part of this first address may have different values, right? And by implementing the Ockam router address protocol in both of these types, I can do Ockam router address dot type, regardless of what type of address this was, right? And I would get a type value back. And then I say, hey, find the message handler. I get back a handler. And then because handlers are functions, another type of polymorphic behavior, I just do a handler and I pass in the message. So this is roughly the routing algorithm that's allowed us to kind of decouple everything, right? And here I could now I could tell you about the message protocol. So the message protocol similarly doesn't enforce the structure of all the messages that could come in. It just says, as long as the message can give me an onward route, I'm happy. You can store whatever else you want in your message. I don't care. This allows what we're doing by having this address protocol, which could there could be all sorts of details in the address, but by having this address protocol and this message protocol, our contact surface with other modules is as small as it needs to be, right? Like it's not, or rather as big as it needs to be. It's not bigger than it needs to be, right? So by having a small contact surface, if the router is changing, the only time we will cause other implementations to change if we decide to change these two simple function declarations, right? If we change the nature of this function or the nature of this function or the signature of these functions, then that will be a problem. But if we change the implementation of these functions, it will not be a problem, right? So by having this like tiny contact point with other modules, this loose coupling idea, the router can change independently. The complexity of the router is self-contained in the router. Each individual module can change independently, and they are free to store any amount of detail in their address fields, any amount of detail in their message fields, and the router is not affected, right? And so we don't have to do like if decisions on different address types or anything like that. Or we still do it on like address type, but like not on any of the other details. All right, so hopefully that answered that question. And then I think there was another one. Your take on TDT test first for creating deep modules, especially for making small surface vector for a module. Okay, that's a good question. So I have struggled to write all the tests first personally. So I do some mix of things. There are some cases where it's really obvious to me what the test should be, and then I write the test first. But then there are other cases where it's not obvious to me what the test should be, right? And so I'll use the REPL-based approach and just go to IEX and try out a few things and figure out what needs to work. And then once I know that this needs to work, then write the test. But writing tests is important. So either whatever the balance is you find where you write all the tests first or you write all the tests after, which I think is generally not good, but like any spectrum, anywhere in the spectrum, different people land. The key thing is write tests because tests are documentation for, it's part of the make your code obvious thing. A test documents the expected behavior of your code. And if it's documented, it's very easy for someone to come in and change your code and know that they didn't break something unexpected. It deals with the whole unknown unknowns thing, right? Because things are checked in a test, if someone changes the code because they didn't know a piece of the behavior that was expected, a test will fail, and that's awesome, right? So by having tests, we make complexity a much it make it easier to deal with complexity. What about property-based testing? So I think both are good tools. They should be used where appropriate. I don't think property-based testing is a replacement of unit tests. Unit tests are behavior documentation. Property-based testing is for scenarios where it's hard to articulate the data set that you want to test against is large, and there are lots of variables possible, and you want some kind of sort of sanity. Then property-based testing is a really good tool, but I don't think it's a replacement for unit tests. It doesn't say you write all the tests first. It actually says as supposed to write a failing test, write production code, the process test, write another test. Yeah, that's I agree completely. I think that's the right approach.
Yeah, I would like to add here something.
Also sometimes.
Yeah, please continue.
Go ahead.
Please go
No,
ahead.
I was just saying that, like, even I was basically confessing that I sometimes don't write the failing test first, right? But what's important about it is that always check that you can fail your test, right? Like, so sometimes if you write a success test and it succeeds, it's not succeeding because your code is doing the right thing. It's succeeding because your success test is bad, right? So make sure you can also fail your test, even if you don't write the failing test first. Go ahead, Sandesh.
Yeah, so we have a few more talks planned for upcoming months. For October, we are in talks to get a speaker around Phoenix channels. I'm in talks and they have responded positively. And for the November one, we are planning a talk around tests. So yes, we should talk Siddhant after this today's meetup. Whom should we invite? And it can be property based test or something else. But for the month of November, we are considering talk around testing our code base of Elixir and Phoenix.
Awesome.
Yeah, if there are no more questions, and I have few questions. So,
Yeah, as do I actually. But I guess I'll wait until Sandesh finishes his questions.
so I like this concept of messaging thing. So if I want to implement messaging of in my app, should I use Ockam or okay? If I want to use Ockam in my app and it's open source,
Mhm.
so how do I
Mhm.
start with? Because it's not on right now on. There's no package right now, I think.
Yes. Yeah. We are early, right, as a project. Our plan is to do a Hex PM release, um, I'd say within the next 2 months, but we're working our way towards it. At that point, I think our documentation will be better, and we'll have examples on how to use it. There's some content already around. I know Sandesh, you shared some of
Yeah.
the videos that we have, etc. The code base is open source. There is a GitHub discussions group there. So we got early access to the GitHub discussions feature. So our forum is on GitHub discussions. That there are lots of interesting questions. So if you look at the code later and have questions, feel free to post them there. We are also eager to get code contributions. So if someone is willing to sort of dig through the code and make improvements, I am happy to do sort of pair programming like sessions to help someone contribute code to the repo as well. So if you're looking to, hey, I want to contribute, but I don't know how to do this, can you do a call with me and do it? I would love to do that. And then in a little bit of time, we will have better documentation, etc.
Yeah, before the next question, a small question regarding helping with open source. So the tags were Elixir and Rust, both the tags were applied to the issues. And if I don't know Rust and I know Elixir and I want to contribute, how do I?
In the Ockam code, you
Yeah,
mean?
yeah. In the
Or
Occam, I've gone through a few issues. There were tags of both Elixir as well as Rust.
Oh, I see. That's a good question. So that probably just means that I should go in and add more issues that are Elixir only. So I'll take that as feedback, and I can add issues that are just pure Elixir changes. And one of the things we're trying to do is make it possible to build our Elixir code without requiring any of the other builds. So for everyone else's context, our code base involves multiple languages. There's C, Rust, and Elixir, and it's all in one repository. So building it for the first time can require, right now might require dependencies in other languages. But the active work we're doing right now is to make sure that the Elixir code can just build on its own. And then building a hardware module C or Rust plugin is only required if you want to do that, right? So, and that was also a requirement before we published our Hex PM package, because we didn't want Hex PM users to have to build C code or that kind of thing. So we're getting there, but there are certainly changes. There are certainly commits you could do on just the Elixir code right now. One to do I'll take here is go and define some issues that are small around just purely the Elixir code, and I can help you then commit if you're interested.
Yeah, the question was from Prakash, like what will be the starting point from the one who wants to start contributing? Mrinal, it would be nice if we can have a one more tag, my first issue. We have same in Elixir
Yeah.
repo, my first issue tag.
Yeah, that would be awesome. We have some help wanted tags on the Elixir, GitHub repo as well, Ockam GitHub repo as well. But you know, this is really helpful feedback, and I will, if I can see people are interested, so I'll take on that task and define some issues. But in the meantime, if you're interested, just send me a message either on Twitter or GitHub or wherever. Right? And
So we have
or
next
email
question,
even.
yeah, by Vinod. How does Ockam integrate with nerves?
Right. So I have done some experimentation. I think we are beautifully complementary, both the projects. I've done some experiments. So for example, I'll give some examples. So let's say if someone is building an IoT device where they're using nerves and they want to use Ockam to do the secure communication aspects, then because Elixir, nerves and Ockam are both Elixir libraries, all someone would have to do is, just like they're using nerves as a dependency, they would use Ockam as a dependency once Ockam is published on XPM, which is it isn't yet. And things would just work. They could, you know, get some sensor data over their I2C bus and establish a secure channel using Ockam, and then take the data they got from nerves and send it over the Ockam channel, right? All of that is super complementary. It'll work really nicely. I think the only barrier currently is we're not yet published as a usable HexPM package.
Yeah, we have a beautiful question by Yugandhar regarding cognitive load. So what information should we read first for less cognitive load while reading Ockam code? Wonderful question.
Yes, that's excellent. So the simplest thing you could start with is the YouTube videos links that Sandesh sent you, and I can post those again. Let's see. I think Sandesh, his email has that link. But if you look for the Ockam YouTube channel, you can find it there as well. But essentially, I created a few very simple, like 5 to 15-minute videos, and there are 4 or 5 of them around how to use the Ockam API. I will confess that it isn't ideal yet. The ideal state would be a good hex docs page that shows you, hey, this is what this piece does, this is what this piece does, and then you have issues documented, but we're working our way towards it. I have attempted to write good documentation inside the code. So if you get past the hurdle of going and reading the code, then I think you'll find at least some of the modules, the important ones, have some bit of documentation. The idea there is being that incrementally over the next 2 months, as we clean up that code and add some documents, then we can just generate the HexPM documentation out of that things in the code itself.
Okay. So if you don't mind, I have a few questions of my own.
Please.
Well, yeah. So earlier in your talk, you mentioned talking about. You mentioned basically, the fact that we should also document the code and also have comments in the code that kind of express what it is you're trying to do within a certain block of code or for a certain function or module. But the thing is, something that's been brought up in multiple talks across the programmer space, that the thing is that code is basically transient. I mean, over a period of time, people will change certain aspects of the code, and many times the comments don't really reflect that. Yeah. So, I mean, how would you go about addressing that issue?
So I think the only way to really address it is code reviews. It's natural to make that mistake, right? Because you find a bug, you see you only need to change one variable to fix the bug, and then you forget that impacts the comment you left like 2 lines above, and you send the pull request, right? And the pull request reviewer also oftentimes will just read the diff, right, and not read the whole function. So it can get missed there as well. But it's just like, yeah, you kind of need to have some habit around it. And if the habit is, I always have comments inside my functions or above my functions, even if the function is a private function and xdoc is fine if I don't document it, I still have comments. Then if that's the convention, then the expectation is set that naturally we should go read the comments just like we're reading the code, because it's part of where our goal is to optimize for readability of the code, right? And so if we keep that as an important item, then we remember it, but there's no perfect answer there because you can totally go out of sync there. And I've seen several cases of where the comment was misleading and that made it harder to actually debug the problem, right? Because the comment made you think something else is happening. Yeah, that can be a challenge.
Yeah, some solutions actually, or some people have actually even suggested that try to make your code as understandable as possible so that it, like you said, code for readability, not for, make it to make everything writer-centric, basically. But basically, what a lot of people have been saying that I've seen at least, was that your code should be readable on its own, and then maybe just add like a line of documentation, just give like an overall sense of what this function does or this module does. And if at all you need to add comments in your code, then write sparse comments that kind of like give the general idea of what you're trying to do, unless if there's anything very specific that you want to address in your code. So I guess
that hasn't worked for me personally. And I think actually the Elixir code base, like the source code of the language itself, is a really good example of writing good comments, right? If you read the Elixir source, there are comments everywhere, right? And I think that that's much better than the sparse comment idea personally. Of course, the code should be self-evident. Of course, there should be good variables, and it should almost read like sentences and prose. That's ideal. Of course, you want that, right? But the subtleties don't get communicated, right? Because code has order. There are conditionals. There are things going on that aren't obvious. In Elixir and Erlang, if you do pattern matching, then your conditionals aren't very obvious either, right? And so your function heads that are pattern matching on different things are basically if conditions, right? And now your if conditions aren't very clear, and if you don't write them down, I personally find it harder to read the code. I love pattern matching because it leads to smaller, simpler code, which has its own benefits. But at the same time, I also sometimes find the need to write a comment above my pattern match saying this is the condition I'm satisfying in the pattern match below. And that particular type of code is especially vulnerable to someone not looking at the code, looking at the comment, because my comment is above all the function heads for that particular function, not just the, so these are all sort of trade-offs, right? Kind of try to balance.
Yeah, I agree. That's actually, that makes a lot of sense. So if you don't mind, I have another couple of questions to ask. So
Take his permission, man. How many minutes can we have? It's late to Mrinal.
Let's do 5 more minutes, and then we'll sign off.
Okay, sure. Yeah, there was a question earlier about ADRs, and I was just wondering, at what point do you draw the line between an ADR, like a small ADR, versus a tactical solution? I mean, because you can effectively, I mean, it's like, you know, after how many grains do you remove, you know, how many grains of sand do you remove before a pile of sand becomes like a grain of sand, right? Like, so at what point do you actually distinguish between like a small ADR versus a tactical solution? Because that could also, that
So
could
there's
blur.
There's a bunch of books around this topic of like domain-driven design that they talk about lots of things, but they especially have this idea in there that talks about boundaries. And and what you'll notice here in the talk that we just had today is it's all about minimizing the contact surface, right? And that's where you get loose coupling, and that's how you get independent modules that can evolve independently, that have their own limited complexity. It's all about like boundaries and minimal touch points in those boundaries, right? And ideally no touch points, or simple connections, not lots of multiple connections, right? Those are the graphs you're looking for, right? No circles. Circles are really bad. I didn't get to touch that in the presentation, but don't end up with circular dependencies. That can be really problematic. But okay, so my personal line is I'm continuously questioning myself and our team around interfaces that touch other modules, knowledge that a module has. So if a module knows about the data types of another module, then you have a problem, right? It doesn't. Then you have exposure. You need to think about that exposure, right? So my personal approach is that anything that is affecting module boundaries should be carefully designed and should have some kind of design decision behind it. Oftentimes it doesn't turn up into a document. In our case, it's usually just people in the team talking, but it's a conscious decision, right? And you could turn those decisions into an ADR. But the point is that the critical ones are the ones around boundaries. The internal ones, if you do your boundaries well, are details that can be changed at any point in time, right? So if you do your boundaries well, then the details can be ignored and you can kind of just run tactically in the details. But keep your boundaries sound, so you are allowed to be tactical, and you're allowed to do a better implementation of the tactical thing you did today, because your boundaries sound. You don't end up, when you go fix your tactical thing, you don't break everybody else's stuff, right? So that's my personal approach.
Oh, that's very insightful, actually. That's pretty cool. If I may just ask one final question before we close. There was a question asked earlier by Prakash about, now that you work with Erlang and Elixir for some time, are there any tools in the Erlang and Elixir ecosystem that you feel are maybe, if not missing, but like they'd be cool if you would have, to add to the tool set that we already have to build these software?
That's a good question. While I think about what's missing, a tool that I've started to really like a lot is telemetry and the libraries that are emerging around telemetry. I think that's awesome, because I have had to build similar things on my own before, because you need to be able to know what's going on in this distributed thing that's moving messages around, right? So I think the telemetry is really awesome, and that work is really exciting. What's missing? I don't know. Nothing comes to mind off the top of my head. I think the tooling in this ecosystem is pretty good. I think the ecosystem is still pretty small. So if you were to ask me what are the things I would like to change, I mean, my first Erlang program was 2006 or so, I think, if I'm thinking back, and now things are a lot better, but back then I was living in Bangalore, and I think there was only one other Erlang person in all of India. that's as far as I know at that time, right? And so the ecosystem's definitely still not really changed. I mean, it's a lot bigger because of Elixir. Elixir made the bar to entry a lot lower compared to Erlang. So the community has been growing, but it hasn't been growing fast enough. So you guys who are organizing meetups like this, I think, are doing a great job in service. So that's awesome. I am happy to help. So beyond this talk, if you need my help, feel free to.
Yeah, who was the other person?
I need to take a moment to remember his name.
Okay. Was it in Bangalore or somewhere?
He had no, he was in Pune, and he had a company, some kind of like ad pop-up company. I remember the details of the company. I forget the name.
Is it NetStratum?
No, I don't think so. That doesn't ring a bell. I'll have to look up. I'll share with you his name, Sandesh. But like literally, there was nobody in the country I could find that did
one
Erlang.
more person like from long time practicing Erlang, Mr. Sanjay Mehta from Haskell Communications. He's in Bangalore.
Huh, interesting. I've never had the opportunity to meet him, but I would love to meet people from India who have been doing Erlang Elixir. So that's awesome. I actually, about 4 or 5 years ago, there was a functional, I think it was the first functional conf. At that point, I met people who were doing Erlang for as long as I'd been doing, or even before, that I'd never met, right? So there were probably more. It's just like there was no means to meet. There used to be a forum called Trap Exit, which I don't think exists anymore. But that was the one place all the Erlang people met and posted questions on. Anyway.
I think we will have to take a hard stop in next 2 minutes, or we have experienced this before that when things start. So I have, so what I will do, if there are more questions, I will definitely mail you, Mrinal, and like with the feedback. And so I will also send him another email to the. Okay, Krishna met you. Wow. Man, Mrinal, I think I can say, yeah. So you are lucky you met Krishna.
Yeah. What is Krishna doing these days? Hey, how are you?
Yeah, I'm good. I'm currently working with ThoughtWorks here. I visited your office, by the way.
In Bangalore?
Yeah, we met.
Oh, that's awesome. Oh, that's awesome. Yeah, I remember meeting you, but I remember the functional conf meeting.
Krishna, was it the same conf I met you, or was it any before conf? Another conf?
That was one before I met you.
Okay.
Anyway, so Mrinal, I'd like to thank you on behalf of Elixir Pune, as well as, I mean, I know Sandesh wants to have a few closing sentences and statements himself, but I'd like to thank you for joining our meetup and sharing your knowledge on Ockam, as well as that very insightful and very thoughtful, presentation on, especially on complexity and how we can deal with it in Erlang and Elixir. If there's anything you'd like to plug or anything you'd like to share with us on something you're working on now besides Ockam or anything else, you can go ahead and share, and then Sandesh can say a few words and we can close.
Well, my only thing is, first of all, thank you all for having me and letting me speak for so long. I really enjoyed it. I hope it was useful investment of time for you. And as far as plugs go, please check out the Ockam GitHub repo. If you're even a tiny little bit interested in contributing something, could be improve our documentation, or could be fix a function somewhere, or anything, like even the smallest thing, send me a note. If you find it hard to do, I will help and work with you so we can get past, and that will be really good feedback for us to figure out what are the hurdles that we need to solve before people can easily contribute, because that was the intent to be an open source project, that we want to grow the community. So please send me an email, and please check out the repo and what we're trying to do with it.
Sure. So just can you put a slide of your contact? That's all. And
Yeah, we'll do that.
yeah. So thank you for accepting our request to join us, and I will definitely mail you with the questions or what we have. Okay. So if anyone wants to reach Mrinal, please tweet him. Reach him on Twitter. He's on LinkedIn also. And if you find any problem, then reach out to me on Telegram or the email calendar invite, and I will be happy to connect with both of you. Okay. So before closing, just next month we are having a talk around Phoenix channels, and the speaker is a well-known person. He has a really great knowledge, and we are just on final confirmations. And once it's confirmed, we will uh, post post it to you again. Okay, that's all from
Yeah.
my end. So
And
thank you, Mrinal. Thank you, everyone. Thank you, the volunteers. Thank you, Akshay, especially Akshay, our new volunteer. He helped us a lot. So thank you, everyone. Bye.
Bye, everyone. Thank you.
Bye.
yeah,
Thanks. Bye.
thanks guys. Bye.